Hi everyone, I am Shamanta MS, Assistant Professor at Physics Department in Maharaja Institute of Technology. In this session, I am going to explain the other unit, that is in Module 3, we studied first electromagnetic waves. So, the next concept is optical fiber. So, what is optical fiber? Here we are going to study what is the optical fiber, what are the applications of that, and what are the types of different types of optical fiber, how that will operate, and what is the main application that is in point to point for communication. So, that we are going to study in this module, that is in optical fiber. So, first optical fiber, how it is made? It is optical fiber is a transparent, flexible. It is how it is looking like. It is like a transparent, flexible, and it is made up of a glass, silica or plastic. So, this optical fiber, it is made up with the glass, silica or plastic, or with the plastic. So, looking like it is a transparent and flexible. So, that means so we can carry for a long distance, and we can place anyway, and its diameter, the optical fiber diameter, that is thicker than the hair, human hair. Okay. So, that optical fiber, when it is one end, it is considered with the two ends, in between that the ray of light will pass. So, the ray of light will travel from one end to the another end without any loss of the signal. So, that totally it will carry the signals from one end to the another end. That information, it will pass the information easily from one point to the another point without any loss of the signals. So, this optical fibers mainly widely it is used in the for the communication purposes, to transfer the data from one end to the another end. So, before this optical fiber, we are using the metal wires, metal cables. So, comparatively that metal cables and electrical wires, this optical fiber will give a huge applications in the technology field. That means it avoid the loss of the signals. Without any loss of signals, it will helps to transfers the signals from one end to the another end, transfers the information from one end to the another end without any loss of the signals. Okay. So, that is why nowadays we are, instead of using the metal cable, metal wires, now we are using this optical fiber. Okay. So, this is it having a wide use application between the engineering and the applied science. And so, that is the field of applied science and engineering, the field of applied science and engineering concerned with the optical fiber, that is known as fiber optics waves. So, the field of applied science and engineering concerned with the design and application of the optical fiber is known as a fiber optics waves. And engineering concerned with the design and application of optical fiber is known as fiber optics. So, that optical fiber that is also known as fiber optics, that is in the case of if the field of applied science and engineering concerned with the design and the applications of the fiber optics. For that we used to call as the fiber optics. So, this is mainly having the wide applications in the field of communication in the technology purposes, that is to transfer the signal. So, instead of using the electrical wires, so nowadays we are using the optical fiber. So, let us study how the optical fiber is constructed and what are the principles of that. It is working on which principles, how the light will propagate inside the optical fiber, how the signals will transfer inside the optical fiber. So, that we will study. Okay. So, this optical fiber mainly it is constructed, the construction of optical fiber construction of optical fiber. So, it is mainly it is made up of the with the 3 layers. So, that is, so how it will look, so optical fiber. So, this is inside is core and the outside is cladding. Inside is core, the outside is cladding. So, this inside that inner layer, so this is we called as core. Okay. So, core, that is having the refractive index N1 and the denser medium. So, this is this region we is called as a cladding with the refractive index of N2. N2 and this surrounding, what is the light ray if enters, so that we is called as the surrounding medium. Okay. So, N1 denser medium and the cladding region N2 rarer medium. So, this is covered with the sheath. This optical fiber, this cladding which is covered with the sheath. So, that is called as a protective layer. Sheath, protective layer. So, this is outer layer, sheath, that is a protective layer. It is made up of a polyurethane. It is made up of with the polyurethane. So, like this the optical fiber is made up of with the inner core, outer core and that cladding which is covered with the sheath. So, that is a protective layer. It is made up of a polyurethane. So, the core. So, mainly 3 layers. The optical fiber, it is consists of 3 layers. So, what are that? So, one is core. So, this core is inner layer, core, cladding. So, core is inner layer. So, core is inner layer. It is made up of with the refractive index N1, that is denser medium. So, inner layer of refractive index N1. So, that is with the denser medium. And this cladding. So, this is cladding is outer layer. So, cladding is outer layer of refractive index N2. So that is rarer medium. So and the outer layer, so that is sheath. So sheath is protective layer. Polyurethane. So it is mainly consists with the of 3 layers. So one inside is core and the outside is outer layer is cladding, and that cladding which is covered with the sheath, so that is protective layer. It is made up of a chemical with the polyurethane. So this protective layer that will covers this optical fiber from the outer, that is maybe rain, thunder, so lightning. So from that this polyurethane will protects the optical fiber. So next, let us we will see how the this optical fiber will works on which principles. So that we will study. So next principle of propagation, how the light will propagate. So inside the optical fiber. So mainly to it is works on the principle of the total internal refraction. So what is total internal refraction? We know that when a ray of light will travel from the one medium to another medium, that is from rarer medium to the denser medium, then that light ray will reflect back to the same medium without refraction, without loss of signals. That ray of light will again it will come back to the same. So that what we used to call as the total internal refraction. So this optical fiber mainly works on the principle of total internal refraction. So we have to know that here mainly total internal refraction, total internal refraction and critical angle. Critical angle. So what is critical angle? For the angle of incidence for which the angle is of refraction is 90 degree. So that angle is called as critical angle, what we used to call. So when a ray of light will travel, so that so this is normal drawn. When an angle of incidence, when a ray of light incident, so this is the rarer medium and this is the denser medium. When a ray of light travel from the rarer medium to the denser medium, so first it will get refraction. The angle of incidence, so this what angle of incidence and angle of refraction. So for which the angle of refraction is greater than the angle of incidence. If the ray of light will get refract, so then the angle of refraction is greater than the angle of incidence. So that is when the ray of when theta, when the angle of incidence is less than the angle of refraction, so at this condition the ray refracted. So the ray get refracted and some part of the incident beam refracted through the then rarer medium. So the ray is refracted. So in this case some of the incident beam refracted through rarer medium N2. So, when theta is less than theta r. So, for which the angle of then when theta I, when the angle of incidence is greater than the critical angle, when the angle of incidence is greater than the critical angle, then the total internal reflection will take place. So, that is the ray of light, it will so for which the angle of the ray of light enter from the denser medium to the, and it will just touches the interface of the denser medium, and again it will reflect back to the same medium. So, that is total internal reflection. So, at this the angle of incidence is greater than the critical incidence. So, for this condition the optical fiber will works. The principle of this, when the angle of incidence is greater than the critical angle, so for which the total internal reflection will occur. For which total internal reflection so when theta is greater than theta c, for which the total internal reflection will occur. So, completely the ray of light will be reflect back to the same medium. So, at this condition. Next, when similarly when theta, the angle of incidence is equal to the critical angle. So, critical like this happen. So, suppose that is now when theta angle of incidence is equal to the critical angle. So, at that point the ray of light interface between the denser and rarer medium. Denser and rarer medium. Interface between the denser and rarer medium. So, that is so the ray of light which interfaces between the denser medium and the rarer medium, for which the angle of incidence is equal to the critical angle. So, at the time the angle of when the angle of incidence is equal to the critical angle, for which that the angle of is interface between the rarer medium and denser medium, for which the angle of refraction is 90 degree. The ray of light for which it is interface between the denser and rarer medium, for that the angle of refraction is 90 degree. So, for which the angle of refraction is 90 degree, which the angle of refraction is 90 degree. So, that is the angle of incidence that is equal to the critical angle. So, the critical angle for which the angle of refraction is 90 degree. So, corresponding to that angle is called as the critical angle. So, the ray of light, it is reflecting back. So, here the ray of light which is the interface between the ray of refraction which is away from the normal line, the ray of light for which it is away from the normal line, and that is interface between the two medium, for which angle we called as also critical angle. The refraction is taking place in between the interface between the rarer medium and denser medium, for which the angle of refraction is 90 degree. So, that we used to call as the critical angle. So, totally the optical fiber which is working on the principle of the total internal reflection at this condition, when the incident ray is greater than the critical angle. So, then the ray of light will travels inside propagation of mechanism. So, that propagation of mechanism. So, that is when a ray of we used to consider the optical fiber. When a ray of light, so that is enters the optical fiber, so that is completely reflected. Right. So, this is in outer inner core is core. So, inner core cladding region. So, that is for this, when the angle of incidence that is greater than the critical angle, then the complete total internal reflection takes place. The ray of light will travel from one end to the another end. So, to obtain a total internal reflection, there must be the refractive index of the core. The refractive index of the core must be greater than the refractive index of the cladding. So, here the refractive index for this propagation of mechanism, the condition is what? The refractive index of the core, it must be greater than the refractive index of the cladding region. So, then only the total internal reflection will takes place completely inside the optical fiber, that is without losing of the signals. That is a light ray. When the refractive index of the core is greater than the refractive index of the cladding, so then only the propagation continues in the optical fiber. So, this refractive index of this is a core, and refractive index of this is cladding. So, then only the light ray will propagates from one end to the another end. So, next is theory of ray of propagation in the optical fiber. How the light ray will propagate inside the optical fiber with the total internal reflection, and what are the principles it includes. So, let us see. So, that is when a ray of light enters from the surrounding medium. So, then how the light ray will propagates. So, when a ray of light enters from at the center the optical axis is there. So, with respect to that optical axis, so the center is the optical axis, this is called as the optical axis. So, inner layer is core with the refractive index N1, and the outer region is cladding with the refractive index N2. So when a ray of light enters from the surrounding medium to the inside the optical fiber, so at the time it made an angle with the optical axis, that is theta naught. So when the ray of light enters, but at the time the sum of the light ray will reflect back. So that reflected back, some of the light ray will reflect back, so that will form an accept cone. So this that forms like an accept cone. So that acceptance cone, we can call it this as the acceptance cone. When the sum of ray of light will reflect back, so then it will take a cone like shape, so that we used to call as this as the acceptance cone, and where this theta naught is the acceptance angle, this incident angle. So then this again inside, when the ray of light enter inside the optical fiber, so that incident ray will make an angle of with the optical axis, so that is represented by theta 1. So that is represented as theta 1. And the ray of light which is here normal to the normal line, it is reflecting here. Then what is the ray of light that will enter inside the optical fiber with the normal line? It will make an angle of 90 minus theta 1. 90 minus theta 1. So this is theta 1, and this is the first quadrant, that will make an angle of 90 minus theta 1. So that is equal to the critical angle. That 90 minus theta 1, that is equal to the critical angle. And when the ray of light will interface that between the cladding and region, so that so this name it has a light ray OA. So when a OA light ray enters into the optical fiber, so that light ray makes an angle. So this is at point B, consider this as at point B. So when a ray of light strikes the optical fiber between the region core and cladding, so that light ray is reflect back to the same medium at the point B, and when the ray of light, that angle of incidence is equal to this critical angle, so at the time what will happen? So this is interface between the core and cladding region. So this point name that has C, name it has C. Okay. So first initially it make an angle, what is that? Acceptance angle, so that is theta naught, and then after entering into the optical fiber, so it makes an angle with the optical axis theta 1. So that is at the core, and then inside with the normal surface, so it will make an angle of 90 minus theta 1. So that is equal to the critical angle. So what angle it will makes? That is equal to the critical angle. 90 minus theta 1 is equal to the theta C, critical angle. So at the same point, that is a interface between the two surfaces. So with the normal surface, by making an angle of refraction of with the theta is equal to 90 degree, the normal. So when the angle of incident ray, that is interfaces between the two surfaces, so for that the angle of refraction, so that is equal to 90 degree. 90 minus theta 1 is equal to theta C, for which the angle of refraction is equal to 90 degree. So that the ray of light which is interfaces between the core and cladding region with the normal surfaces, and that makes an angle of 90 degree. So, and the next, the ray of light which enters, the ray enters the optical fiber is less than the theta naught. Is less than theta naught. So, what is the angle of incidence that ray, this theta 1, 90 minus theta 1 and this 90 minus theta. So, this light ray which is angle is less than the acceptance angle. So, then only the total internal reflection takes place. So, for that total in the ray enters the optical fiber is less than theta naught, which the angle of incidence for which the angle of incidence 90 minus theta 1 is greater than the critical angle. So, then the total internal reflection takes place. So, for which so when the light of when theta naught is greater so than the angle of incidence, so then the total internal reflection takes place, for which the 90 minus theta 1, for which the angle of incidence 90 minus theta 1 is greater than the critical angle. So, then only the total internal reflection will take place inside the optical fiber. Okay. So, suppose if any ray theta acceptance angle is less than the incidence angle, and if any ray theta naught is less than the theta 1, then what will happen? The ray of light will enter inside the optical fiber, so that will refract through the cladding region. So, the ray of light will reflect through the cladding region, and what is the data and the information will be lost in the optical fibers. So, the ray of light will emerges out from the cladding region. So, at this condition when theta naught is less than theta naught, so then the ray of light emerges out through the cladding region. So then the ray of light will be lost in the optical fiber. So, these are the theory about the optical fiber. So, next what is the condition for this optical fiber? So, for that we have to derive the derivation.